Hello all. Hardware engineer doesn't design any circuit without using a decoupling capacitor, right? A decoupling capacitor is something which is placed between the power and ground pins of a IC used in that circuit. So what role does a decoupling capacitor play? Okay, everyone, if you ask, the first role that is played and explained by each and everyone is whenever there is a transition, like example, let us assume we have connected a load, okay, and the IC tries to supply current to that load. In that case, it has to supply from the VDD only, right? And what happens is this VDD need to be sourced from here. That means from the power supply or somewhere. So when such sudden current draw that happens due to the load, this IC should be able to supply that current, and that current locally will be supplied by the capacitors here. Okay, so this capacitor basically acts as a bank there and helps to provide the required instantaneous current that happens because of the current drawn by the load. That is the first thing which everyone explains. Now, second thing, okay, the main point about this is noise. So, what happens is these particular capacitors that are placed very close acts as noise filters. So, these capacitors help us to provide low impedance path between the power and the ground. As in here, this acts as a low impedance path and helps to eliminate any noise that is spreading onto the circuit. Like for example, when there is an IC, okay, and this IC switches, right, definitely there'll be some noise that will be introduced between the rails of this particular IC. So this IC might propagate this particular noise to the other section of the circuit, and these particular capacitors helps us eliminate spreading of that noise to other circuits. So that's the biggest advantage. So that's about the noise. The first thing is about the current that is being supplied, instantaneous current, which is basically the banks, and second thing is the noise, and third most important point is, let us assume we don't have these caps, we don't have this cap, and there is a supply here. Let us assume there is a supply, DC supply, which is supplying the voltage, and this actually is switching. Now what happens is the noise that is generated across these terminals and also the instantaneous current will actually pass from this and again returns back to the DC supply, which forms a huge loop, and this actually uh, introduces noise onto the system, right? Now let us assume a scenario where you have the capacitors very close. The actual loop between the ground and supply will be through this small area near the IC because of the decoupling cap that is placed there. This is another reason why we need to keep cap as near as possible. The reason is because of these two scenarios, and also the third reason which demands to place it as close as possible so that you reduce the loop area of the current. So many advantages, right? Decoupling caps are like a shot in the arm for electronics hardware design engineers, and in case if there are any other things which I'm not aware, please try to post in the comments. Please correct if you find any corrections in the points I have raised. Thank you.